This is number 8. A diesel train traveled to Las Vegas and back. That's a key sentence there. You travel somewhere and back, you're traveling the same distance. That's very key to this problem. Very key to this problem. A diesel train traveled to Las Vegas and back. All right, so you're traveling there. That's right there. Distance there. I'm going to use psychology on the, hey, don't call in. I don't want anybody to call in. Just leave me alone. Leave me alone. Don't bother me so I can just do these problems in peace. Trying to use reverse psychology. Don't call in. Whatever you do, don't call in. Leave me alone. All right? They told me that I was too boring last week. So I have to bring some life and energy, so that's what I'm doing. Don't call in. Leave me alone and let me do these problems in peace. Thank you very much. All right, so the distance there to Vegas, and then we got a distance back. The distance is there is the same as the distance back. So we got D is equal to RT. D is equal to RT, both there and back. All right, the trip there took 5 hours. The trip back took 6. So that's pretty basic there. So let's substitute in 6 for the trip there. Substitute 6 here. And, the trip there took 5 hours. I'm sorry about that. The trip there took 5 hours. And the trip there took 5 hours. The trip back took 6 hours. All right. The problem says what? By the way, I'm reading these problems very carefully. You should do the same as you take your test. What was a diesel train's average speed on the trip there if it averaged 35 kilometers per hour returning trip, on the return trip? Another way to say return trip is the trip back. All right, maybe I should have labeled this better. The trip back. All right, so the average, what was the diesel train's average speed there if it averaged 35 kilometers per hour going back? So they're giving you 35 kilometers. Let's give myself a little bit more space here. 35 kilometers per hour. They gave you that. And it traveled 6 hours back. Hours cancel. And you're left with the distance traveled back was 35 times 6. 35 times 6. All right. 35 times 6. I believe I did that calculation. Yeah, I did that calculation already. That is 210 miles. I did that calculation before we started the show. So that's 210 miles. Now, the important thing about this problem is the distance that you travel there is the same as the distance you traveled back. So what you can do is you can substitute the same distance that you traveled back into the distance there, because again, it's the same distance. So you get 210 miles is equal to the rate, which is unknown, times 5, which was given in the problem as the distance that it took to travel to Las Vegas for the train. So it's easy to solve for R, basic algebraic equation. You divide by 5 on both sides, and you're going to get R. I've done this already. You end up with 42 kilometers per hour. Final answer. 32 kilometers per hour. Final answer. What an odd name. You don't meet too many people named Mofor. Mofor left the White House and traveled toward this recycling plant at this speed, 70 kilometers per hour. All right. Jill left 2 hours later in an opposite direction. All right, so let's draw a good diagram. All right. All right, so we got Mofor, and we have Jill. Mofor and Jill. Mofor left the White House and traveled toward the recycling plant at an average speed of 70 kilometers per hour. So they give you, again, distance is equal to rate times time for both individuals. Distance is equal to rate times time. All right. So Mofor left the White House traveling toward the recycling plant at an average speed of 70 kilometers per hour. I'm going to make that substitution right away. 70 kilometers per hour. Jill left 2 hours later. Jill left 2 hours later, and she was traveling in the opposite direction with an average speed of 35. Let's substitute that. All right. 35 kilometers per hour. But see, it appears as though Jill left 2 hours later. That means Mofor had been traveling longer. Jill left 2 hours later, so that means that Mr. Mofor was traveling a distance longer than Jill. All right. It says that Jill left 2 hours later in the opposite direction with an average speed of 35. Find the number of hours Jill needs to travel before they are 350 kilometers apart. So they don't really tell you the times that each of the individual traveling. They just tell you that Jill left 2 hours later. So that means that Mofor was on the road for 2 hours more than Jill. So let's identify that mathematically by just saying T plus 2. T plus 2. Mofor was traveling for 2 hours longer than Jill because Jill left 2 hours later. And let's just use T for Jill. So you don't know the times, you just know that Mofor was traveling for 2 hours longer than Jill. So Mofor could have been traveling for 6 hours, which would force Jill to travel for 4. See, Jill left 2 hours after Mofor. So the way you identify that mathematically is to use a variable because you don't know the time. So you put T there. So if Mofor was traveling for 2 hours longer than Jill, you identify T for Jill and 2 plus T for Mofor. You got to use variables there because they don't give you times. Now they say that Jill left for 2 hours later and traveled in the opposite direction with an average speed of 35. We've already acknowledged that. Find the number of hours Jill needs to travel before they're 30 kilometers apart. Or excuse me, I said 30. I meant to say 350. So this distance is 350. This distance is 350. All right, so you got a distance that Jill traveled, rate times time. You have a distance that Mofor traveled, rate times time. Well, these distances have to add up to be 350. So that is an algebraic equation. This distance for Mofor is 70 times T plus 2. And this distance that Jill traveled is 35 times T. These distances added together have to be 350 according to the problem. Now, this is just basic algebra. You got to distribute the 70. You get 70 T plus 140 plus 35 T is equal to 350. Basic algebra equation. If you had algebra, you got to add these like terms. You get 105T plus 140 is equal to 350. You need to get everything, get the constants together, get the variables on one side, get the constants on the other side. You're going to subtract 140 on both sides. Subtract 140 on both sides. You end up with 105T is equal to 210. Divide by 105 on both sides. Divide by 105 on both sides. And you're left with T is equal to 2. All right, so T is equal to 2. So the time that Jill was traveling was 2. The time that Mofor was traveling would end up being 4. Jill needs to travel. Find the number of hours that Jill needs to travel. The answer would be 2. Final answer. Final answer.